Average rate of change tells us how much a function changes on average over an interval. Say, for example, we are given this function, then, and this point is x1, while this point is x2, then the average rate of change looks at how much the function changed overall over this interval. So formulaically it can be written as delta y over delta x is equal to f x2 minus f x1 divided by x2 minus x1. Okay, now I will do some problems to illustrate how to find average rate of change. So, looking at problem 29, f of x is equal to x cubed plus 1. We are asked to find the average rate of change over the following interval, 2 to 3. Then, using the formula, I have delta y over delta x is equal to f3 minus f2 divided by 3 minus 2. Writing out my function, I have 3 cubed plus 1 minus 2 cubed plus 1 divided by 1. Solving this, I get 28 minus 9 is equal to 19. For part B, I am given a different interval, minus 1 to 1. So once again, using my formula, I have delta y over delta x is equal to f1 minus f minus 1 divided by 1 minus negative 1. Then writing out my function, I have 1 cubed plus 1 minus negative 1 cubed plus 1 divided by 2. Simplifying it, we get 2 minus 0 over 2, and this is equal to 1. So, although we're dealing with the same function, at different points on this function, the rate of change is very different, and we can see graphically that around the origin it slows down, and as you go further to the right or to the left, the function begins to change much more dramatically. Okay, looking at another problem, number 30. The function here is g of x is equal to x squared. Part A, the interval is minus 1 to 1. Using the formula again, I have delta y over delta x is equal to g1 minus g minus 1 divided by 1 minus negative 1. Writing out my functions, I have 1 squared minus negative 1 squared divided by 2. So I have 1 minus 1 divided by 2, which is 0. And it makes sense because in this case, this is a quadratic function given by this graph. And we are looking at these 2 points. As you can see, our function, the delta y, between these 2 points is 0, so it doesn't change. Although it changes on average, it goes down and then goes up, and overall the effects are cancelled out. For part B, I am given the interval minus 2 to 0. Here, using my formula, I have delta y over delta x is equal to g naught minus g minus 2 divided by 0 minus negative 2. Writing out my function, I have 0 squared minus negative 2 squared divided by 2. Solving it, we get 0 minus 4 divided by 2, which is equal to minus 2. Alright. Now looking at the next problem, I have problem number 31. I have h of t is equal to cotangent t. Part A asks me to find the average rate of change over the interval pi over 4, 3 pi over 4. So once again, using my formula, I have delta y over delta x is equal to h 3 pi over 4 minus h pi over 4 divided by 3 pi over 4 minus pi over 4. Writing out my function, I have cotangent 3 pi over 4 minus cotangent pi over 4 divided by 2 pi over 4. Cotangent 3 pi over 4 is equal to minus 1. Cotangent pi over 4 is equal to 1. And then denominator I have pi over 2, which is going to be equal to minus 4 over pi. So the way we know that cotangent 3 pi over 4 is equal to minus 1, or cotangent pi over 4 is equal to 1, is because cotangent of t is equal to cosine t over sine of t. And although we don't need to have memorized what cotangent of pi over 4 is, it is usually expected for us to remember that sine of pi over 4 is equal to square root of 2 over 2, and cosine of pi over 4 is equal to square root of 2 over 2. And using these relations, we are able to find what cotangent pi over 4 is, and also using some graphical considerations, the fact that sine and cosine, the values of sine and cosine give us a circle. Using the graphical consideration, we are then able to find, and then using graphical considerations, we are able to find what cosine 3 pi over 4 is equal to, and what cosine 3 pi over 4 is also equal to. Alright, so for part B, I am given the interval pi over 6 and pi over 2. So delta y over delta x is going to be equal to h pi over 2 minus h pi over 6 divided by pi over 2 minus pi over 6. Writing out my functions, I have cotangent pi over 2 minus cotangent pi over 6 divided by 3 pi over 6 minus pi over 6. So the value of cotangent pi over 2 is equal to 0, and value of cotangent pi over 6 is 1 over square root of 3. And it's all divided by pi over 3. Simplifying the equation, I get that the rate of change of my function over the given interval is square root of 3 over pi.